All right. I so could you just introduce yourself really quick?
Hello, my name is AJ. I am a first alumni and currently working as a software engineer for a little company called Code Sandbox.
And what are some cool and interesting projects you've developed throughout your job there?
I've had a few different jobs on a few different teams now as a software engineer. Probably my favorite was working on software that helped you to learn how to code. This was at a previous job that I had. And one of the difficult parts about that was giving you a place where you could safely type code and test it out in a way that didn't require you to install anything on your computer or didn't risk breaking anything. We just had to make that special sandbox environment for you to run and learn in. And just managing those environments and the way that we tested how far you've gotten in the course, that was really fun.
That's actually very cool. So from the skills of robotics, hardware and software wise, how does that transfer to your job?
It's, to be honest, occasionally difficult to see how it transfers because I think if you are in first for a long time, especially if it's something you do like all 4 years of high school, or even more than that, like I was in first Lego League as well as FRC. So I had many years in that first mindset. It's hard to see how it impacts you, but it really does. So just to throw out some examples, like if you happen to be on an FRC team, for example, you have a really set build season. And I think in FTC we have something a little bit similar. The time between kickoff and the first meet that your local league has, it's not a long time necessarily, especially lately, that the time's been getting shorter and shorter. So being able to look at the problem in front of you and understand what are the important parts that must be accomplished first, and then what do you want to maybe develop later. That is something you do constantly in software development because you never have enough time to do everything. So you have to truly evaluate what it is that you need to do in order to get anything to work, and then prioritize the steps after that based on what's going to bring the most benefit to you and the people you're making it for.
So I have a follow-up question. How do you know what's gonna benefit the people and what's not gonna benefit the people?
That's tough. In software, we don't have points, right? Like you can make a matrix for the scoring in a first game and get a pretty good idea like what is most worth your time based on your estimated level of effort and how many points you can accomplish because of that effort. We don't have points when
Yeah.
we're developing a product. So you have to get an idea of what is going to be most impactful based on, in my case, actually going out and talking with the customers, the people who are going to use your product. Um, with software, it's really nice because unlike developing a physical piece of hardware, you can change the software really quickly. So you can make something, test it out, put it in front of people, see if they like it, and then a lot of times just go back and make changes to it afterwards. So it's all about taking that cycle, the time it takes for you to have an idea and implement that idea, and then go back and see if it's actually working. You want to make that amount of time as small as possible. And that works for software as well as first teams. You prototype an idea, try it out, see if it's working, and then move on to the next one.
Yeah.
Yeah, I
And
think that really applies for us because like this year especially there's been so many different aspects of the game. So there's like 3 to 4 different separate models that we need to prototype and like improve on throughout the year. So that definitely like we can see the application there for sure.
Definitely. Like this year's first tech challenge game, like you said, it has so many different aspects. It's so diverse in the way that you have to interact with the portions of the field. I think the game design committee did a really great job. And yeah, it forces you to really make those prioritization decisions, which I think is a skill that you're going to use pretty much no matter what job you have in the future.
so yeah, based on what were you saying? Based on communication, I know communication plays a very big role in like robotics teams, especially with us. Could you talk a little about like how communication plays a role in your day-to-day job life?
Yeah, I'll kind of talk about it in two different examples because right now I'm working on a team where the people I work with every day, it's just a team of two of us, like me and one other person. So obviously communication there looks a lot different than a bigger team like I've been on in the past. So regardless of the size, you all have to make sure that you have a few key things. First is that you're speaking what a lot of people call a ubiquitous language. You're using the same words to describe the same things. Like in a first team, you want to make sure that when you're describing parts of the field and potentially parts of the robot that interact with the field, you're using the official terms that are in the game manual because those are terms that we can all agree on. And as long as you use those terms, everyone knows what you're talking about. So that ubiquitous language is really important. And then when you are setting out your plan, it's important to regularly, even every single day, check in and make sure that you all understand, like, in this big plan that you've laid out of how to get from here to where you want to be, where are you? And that may look like in software, it's often a daily stand up meeting that just means that you share what you've been working on, if you have run into any problems, that sort of thing. On a first team, it can look exactly the same way, just making sure that everyone involved has the same mental picture of where you are on that line between where you started and where you're going.
Right. So I know you said like every day you basically evaluate your plan, and I bet many teams want to know like how you make sure you evaluate it properly, know where you are.
It's tough because in software development, sometimes if you're lucky, you get data that you can use that will tell you with a number, like, yes, you are doing the right thing and it's working, or no, it isn't. Um, on a first team, you don't often get that unless you, for example, are constantly doing your driver practice and seeing how many points you can put on the board in a 2-minute period. So there's always this tension that you have, whether it's on a first team or in software development, of taking a little bit more time in order to get the data you need to know if you're doing the right thing versus spending that time potentially getting even further towards where you want to be. Like that, there's a trade-off there. And if you spend all of your time just doing the research and doing the practice, you're never going to get anywhere. So you can definitely go too far in that direction. But if you don't spend any time doing practice or spending time implementing the software you need to know if the analytics are showing you what you want to see, then you'll probably end up going off in some weird direction and not end up where you want to be in the end.
Right. Parth, you're muted.
Sorry. So, yeah, I think you covered a little bit about that in terms of the plan, like teams have to, you have to make some changes and stuff. But overall, adaptability is a really important trait, as we've seen in robotics, where like if you're at a competition and something breaks or you need to make a big change, you need to be really, you need to be able to do that. So, is like the in your job and stuff, is that important also? So like, is your product built to be easily changeable or fixable?
Yes, there is a tension and a trade-off to be made there because it is possible, and one of the big dangers in software engineering is that you'll spend a lot of time trying to make the code so flexible that it could do many things, but you're never going to do those things. So you've wasted a bunch of time, and you've wasted time that you could be using evaluating which one of those things you need to do. So you're kind of in the same place. You don't want to just go out and build a robot that is an 18 by 18 brick with a bunch of holes you can, put things on, and like that's not going to work out. It does need to have some sort of design. You have to make decisions that prioritize one thing over another. I think a lot of times we're scared to say, like, we value this over this. We want to do this portion of the robot game more than we want to do this other portion of the robot game. But those decisions are the most important. And as you're making them, you are losing flexibility in your design. And that's okay. As long as you recognize that you may want to revisit it later and be a little more adaptable and revise it, you can always do that. Just keep in mind how much time you have.
Yeah, I think just that's very important. Just keeping making sure you know where you are and everything. Stemming a little bit off of off the current planning topic. Robotics teams, of course, like in tournaments, you have to submit your portfolio and you have to have auto and stuff like that. So they're composed of people with very diverse skill sets. So in the industry where you work, is that also the case where there's a lot of people with a lot of diverse skill sets, or do you see more of a
Oh yeah, and the I would say the most common way that people work in a software development team that is focused on like software that you put on the web is in what is called a cross-functional team. And this is exactly like you have on a first team. You have people whose careers are in different fields, but they're all focused on the same thing. And sometimes the software developers are the majority of that team, but not always. You will always have some influence of someone who's more of a product manager, who is really good at going out, talking to customers, and understanding which parts of the thing that you're building are more important. This would be probably someone with a little more experience on the team in the context of first, someone who has probably seen a few robot games and they understand which portions of the field are the ones to focus on and can help set that direction. We also always on a software team have someone who's really good at design, because it turns out that people who code, and I say that as someone who codes, we're not the best at making things look good or be usable. So you have to have that influence in the team as well to make sure that the product you're making can actually work for real people. And I think, like, just to throw an example out there, the influence of the people who are going to be driving the robot needs to take charge on that. Like, if there is a way that you can change the design of your robot to make it more drivable and make the drivers, work with it more intuitively, work with it in a faster way so that they can get more points on the board, then you need to have that influence in there too. And there's all sorts of other professions that may be involved as well. You can have data scientists, for example, on the team that help you make those decisions and all of that.
yeah? So yeah, that's definitely that shows that there's the different skill sets exist in the industry also. And then we talked a bit. I think we talked a bit about this with the adaptability concept, but in robotics, there's often times where we face like a major setback in a tournament or something. So like for example, in a meet this year, our claw broke and we had to figure out how to fix it immediately, or our auto stopped working. And we had to make some quick fixes to change that. So have there been times in your job and stuff where you faced a major setback in production and have had to like act quickly to recover from this?
Yes, definitely. And I think my ability to respond to that situation was greatly helped by my experience in first. Because what, this will sound weird to hear, but one of my favorite memories was with my first robotics team at the Orlando Regional, and I believe it was my second year. We basically just shredded one of our encoder cables. Like, it was deep down in the bot, it got caught up in something, and it was just gone, right? And of course, this is one of the cables that is snaked through the entire robot. We have to take half of it apart in order to fix it. But in that moment, what I experienced, at least the way that I remember it, is there were many of us in the pit working on the bot, and we weren't saying anything. Because in that moment, we all knew what needed to be done, and we didn't need words to express it. We all had the same image of what we were about to do, and we were just in a perfect flow state of just making it happen. and like people grabbing the tools that we need right when they needed them and handing it off to people. Like, it was great. I will always remember that moment. And the the thing that I took away from that as a student, looking back these many years later, was that when problems arise, your ability to react to them becomes much better if everyone involved knows how you got there and knows the right priorities of what needs to be done to fix it. If everyone is just sort of running around not sure what to do, that's when you really run into problems, because you'll end up making things worse along the way. So, in some situations in my professional career, I've been in those situations where we all knew what needed to be done. We had a meeting and we said, hey, this isn't working. We need to make some really important changes. Let's go do it. And we did it. And all of those situations were, in the end, very successful. Other situations in which we were just sort of blindsided by something and there was no clear leadership, or no clear prioritization of what is the most important thing to tackle first, that's when we really ran into problems. And an issue that could have been solved in a few hours started stretching out into days and weeks. So, what that means in practical terms is, as a team, you need to understand, like, what are the parts of your robot, or what are the parts of your software product that are most important? What are the non-negotiable things that you must have? And then, kind of in order, what do you need to build on top of that to be more successful? And you all need to agree on that. And when something goes wrong, you should be empowered to make the decision that, you know what, we're going to take that part of the robot and just throw it away for the rest of the day, because it's going to take too much time to repair it or replace it or whatever the case is, and we can do okay without it, because we all know that we can do okay without it. That is a type of discussion that's difficult to have, and it's something that you should really have not in the moment. You should have it ahead of time.
Yeah, and I think that's something that we implement on our team also. So like everyone in the competition knows exactly what they're doing. So if you're making change to the auto or getting like making sure the batteries are always charged or something like that, it's just everyone knows what they're doing. So everything hopefully runs smoothly. So it's obvious that like you've taken your experience in first and now you're an FTA, of course, for Florida. So first of all, we greatly appreciate all your help throughout all season stuff. But
Thank you.
if you wanted to talk a little bit about like your experiences in FTA, maybe how you started becoming this FTA, and I know you wanna, yeah, so.
FTA is a really weird role. First, technical advisor. It got a bit of a rename recently, last year. So it used to be field technical advisor, now it's first technical advisor. And just to make sure everyone listening is on the same page, the real goal that I have is that every team walking away from the field after a match knows what they need to do next to be successful if their robot did not perform the way they expected to. That's it in a nutshell. Everything else that I do is secondary to that goal. Like all of the technical crew, whether you are officially an FTA, FTA assistant, control system advisor, or even, if you are working as a field inspector or robot inspector, everyone on that technical crew is there to make sure that the teams succeed. So one of the most important things that I ever got from the many mentors that I've had, who are also FTAs and still around to this day, is that mission. Like, we've set the highest priority, so we know what's most important, and that's what we're here to focus on. That is like the most important guidance you can give to anyone in any job or volunteer role or anything. We've set like the North Star that we need to follow. After that, being an FTA is all about problem solving. Something's not working on your robot. Why is it? Now, my experience as a first alumni definitely helps, because I have the experience with wiring and electronics. They weren't the same wiring and electronics that we use today, but the same ideas apply. And it helps me to step through like what the problem might be, because frankly, I've been around for a while and I've just seen more things go wrong. So I have that internal Rolodex of things that might be wrong. But anyone can do the job because anyone can take the mindset of, okay, I know that power starts here and it ends up here, and somewhere in the middle it's broken. Let's start at both ends and find out where the break is. Where's the seam? Anyone can do that. And if you have that deliberate, methodical problem solving thing, then you can succeed in any technical role in first. I truly believe that. Now, I'd like to say that my software development career has helped me to develop that, but honestly, it's the other way around. First helped me develop that mindset, which made me a better software engineer. It's definitely like first came first.
And one question I also had, like a follow up, is what is one of the most like common technical problems during FTC competitions, and how do you typically like assess them?
The hardest problems to solve are the ones that don't happen all the time. So I think probably uh, everyone in your local league, everyone who's listening to this, has probably experienced some sort of power issue. One of the more common issues we have right now are the XT30 connectors on the Rev Control Hub or Rev Expansion Hub. There's a part of that connector that's like a little flower that it kind of expands to meet the thing that's going over it. And over time, that little flower part of the connector gets compressed and really tight. So it's loose inside and it doesn't make contact. And everything is fine until you run into one of the trusses on the field and suddenly it shakes loose for just a few milliseconds, and that's enough to make you lose power and the whole system resets. So that, just because of the age of the modules we're working with, that is one of the more common problems right now. So when I'm addressing a robot that might have a power issue, I always start at one end, like battery. Okay, let's go to each of the connectors, like from the battery to the switch, and from the switch to the control hub. Let's just move them a little bit. Is it loose? Can I make it repeat the problem? Can I reproduce the issue manually by physically touching this robot? And we just keep working our way along. And maybe the problem is right there at the beginning, and it's actually your battery switch or some part of it that is loose, and just by looking at it and tapping on it, I can make the robot lose power. And then I can say to the team, this is the part you should look at or the part you should replace. Maybe it's a little more complicated. It's like the wire going from your control hub to your expansion hub, like kind of way down the line there. And it takes a little while to go and find it. But that methodical mindset of starting at one end and going all the way to the other end until you find the issue, whether it's power, whether it's a servo not working, whether it's a sensor not working, you can still use that same process and achieve the same result.
And like collaboration and teamwork again. So like how do you collaborate and like ensure teamwork among other teams and helping other teams with other volunteers?
I am extremely lucky here in Orlando specifically and in Florida in general because we have so many incredible technical volunteers. These are the people who taught me how to do my job, and they're still around. And they are so gracious in the way that they've allowed me to step into the FTA role and start taking things over for some of the things, and still being around to help out despite that. Like that, I'm so lucky to have that team around me. And when you're working with any team, whether it's a team at work where people are literally paid to be there and to do their job, or whether it's a team of volunteers like this that you're not being paid to be there. You're there because you care, presumably. Otherwise, why would you have gotten up early on a Saturday morning to show up there? Uh, you still rely on different skill sets, understanding like this person, he works as a software engineer. So if a team is having trouble with their autonomous code, I'm more likely to ask this person to help that team than this other person who is much better at electrical engineering, and she's incredible at that. And if the team is having a wiring problem, I'm going to hand them off to her instead. Um, that's not to say that any member of the technical crew in Florida couldn't handle all of those problems, because they're all amazing. But you start to understand where people's strengths are, and as you progress in your career, whether that's in software or building things, engineering, whatever, you have to understand, like, this group or this individual has certain skills that I can rely on, and I can ask them to help out in certain areas. The exact same thing happens for teams as well. Some teams are stronger in some areas. I know some teams locally that are absolutely incredible when it comes to programming, and not just really great programmers, but really great at helping other teams understand what their programs are doing. That's like, that communication aspect of it is critical. Other teams can build, as we've seen, the most amazing robots. And if something's not working right, if they're having trouble, like a servo's not, a team has a problem where their servo is not doing what they want it to, this other team can come in and help out, and they know exactly, like, okay, this servo has this limitations, and if you switch it out for this other one or buy this other part, you'll have more success here, like that sort of thing. Understanding the strengths of the resources available to you and deploying them is incredibly important.
Yeah, that's definitely an important point. I feel there's like, I know you talked about some common problems, but if there's any like recommendations that you would have for both rookie, I mean, of course you see newer teams having these wiring issues and stuff more, but I mean we see it all the time, and even the recent league championship, a lot of disconnections and stuff. So what advice would you give to teams in general, like not only power but new teams, or just what advice would you give to them when competing and stuff?
Yeah. There is a document called the Robot Reliability Guide or Checklist. I feel like no one knows about it, because I think most of the problems that we see on the field could probably be solved by going through that checklist. But even just to back it up a little bit, there are resources available from FIRST. The robot inspection checklist, field inspection checklist, robot reliability guide, or control system troubleshooting guide. All of the answers that I use to help teams during competition day are there. You don't need me for it. I'm obviously happy to help out, but you truly don't need any of the technical volunteers at your disposal to solve these issues. The problem is they're long. They take a long time to go through. There's a lot of technical stuff in there, and a lot of teams, frankly, don't have time. But where you can start as a team, regardless of how experienced you are or how experienced the students on the team are, you can start with the field inspection checklist. Making sure that when it comes to field inspection, you know that you are absolutely ready to go before you show up at the competition. And when you're feeling confident about that, move on to the robot inspection checklist. Make sure that you get to a point where there are no surprises. And when you're feeling confident with that, move on to the robot reliability checklist. That's going to be like the top level. Like, if we can go through this checklist and we are confident at how our robot is built, we know that we're not going to have any problems throughout the day. And then you make your own checklist. I often say, like, I wish more teams had checklists when they come to the field, because it's easy to forget things. It's easy to set up your robot incorrectly because there's so much to do when you set it down on the field for a match. So make yourself a checklist and make sure that you never go another match forgetting anything. And you always know which program to run, how to set it up, what orientation, all of the details. They're all written down, so in the moment, you don't have to stress about it.
Yeah, and I think that point is very important. Like we always have like a pit checklist and a field checklist of stuff to bring to the field and pit, so we're not like scrambling at the last minute to pick up something that we forgot.
It's so important.
Yeah. Um, I think that about wraps it up for my questions. Gil, did you have anything else to?
No, that wraps it up for me too.
Thank you again. Thank you for your time, and we're excited to see you in 2 weeks at the state championship, and we're hoping to have a good day there. But yeah, thank you
Yeah.
for coming on and sharing all your knowledge. And we truly were able to learn a lot from this
Yeah,
interview. So
thank you. I hope you don't mind if I plug. I have a YouTube channel. It's youtube.com/
mhm.
at FTAAJ, and I make content about how to make your robot more reliable and things like that. So if you want to check it out, please do.
Yeah.
For sure, everyone, please check out his channel. And I've seen that you've definitely have some very informational videos on there. So
Thank
yeah,
you.
thank you for everything that on that, and thank you for coming here today. So
Yeah, thanks for having me.
Oh,
yeah,
thank
no
you.
problem. Bye. Thank you.
Bye. You just